you're asked to find the derivative of a function f of x equal to x minus 3 times x plus 1. Now, so what is that question asking? Well, here's the important thing. The derivative, I'm just going to define the derivative for you. Because, again, if you're not clear through all these videos what the derivative is, you're not paying close enough attention, okay? So the derivative, and you should write this down if you don't know it, but the derivative is a new function based on the old function f of x up here that gives, with an input value, it gives the slope of the tangent line to the curve, which is the output value of the derivative. It's the slope at the x value that was inputted, or at the domain value. Let me say domain value because it doesn't have to be x. At the domain value that was inputted. I don't know if there's two t's or not, if that's even a word. Okay. But the idea is this. F prime is a whole new function. And the input in f prime is still a domain value, but the output is not a y value anymore. It is the slope of the tangent line at that x value. So the picture is this. If you've got some function like we do here, f of x being equal to, let me draw that out just a little bit better so that so this is clear. Now this function has intercepts here at -1 and at +3. It's upward sloping. It also hits down, let's see here, down here somewhere at -3. Looks like something like that. So it probably comes up like this and up like that. Now, what is f prime? So this is f of x. Well, f prime of x is a whole new function. Okay, it's related to f, but it's a whole new function. What does it give us? If we give it a specific x value, like let's say 2, and we go down, and we find where 2 hits the graph, and then we draw in a tangent line, f prime at 2 is equal to the slope of this blue line. Okay, so f prime has got to change because as x changes, man, the slope changes. Look, if x is over here, the slope is negative. If x is over here, it's negative, but it's even more negative. If it's down here, look, it's 0. Okay, so it's got to change. So f prime is a whole new function. So let's take this function up here, f of x, and let's find a new function that tells us the slope of all these tangent lines. So f prime of x is going to be equal to f at x plus delta x minus f at x over delta x. And if you're saying to yourself right now, where did x0 go? We were using x0 before. Guys, it doesn't matter. Look, f prime at something is equal to f at something plus a little bit minus f at something over a little bit. If you want to, and I'm beating this to death here, if you want to put a smiley face in there, then it's f at smiley face plus a little bit minus f at smiley face over a little bit. It doesn't matter. Okay? It really doesn't matter what you use for your variable, and you need to get used to not always using x's. Okay? Because it becomes confusing then. You know, as soon as someone changes a variable, all of a sudden we're talking about, I don't know, volume into the radius, right? We're talking about a function that's volume in the radius, and now you got v's and r's floating around in there and not f's and x's. and it gets confusing for students if you don't get used to playing around with different variables to begin with. So enough about that. Let's go ahead and talk about actually evaluating this guy. Well, this guy's not too hard to evaluate because we already have the function here. Now, my recommendation is you can either take the function and multiply it out. Okay, so you can use this, x squared minus 2x minus 3, or you can use this original. Really irrelevant. Okay, so f prime of x is going to be equal to this guy plugged in. I'm going to use the second one here. So it's going to be x plus delta x squared minus 2 times x plus delta x minus 3. That, ladies and gentlemen, is this piece right here. Now we need to subtract off f of x. Well, what is f of x? It is x squared minus 2x minus 3. We need that guy in parentheses. Well, what is that? This guy in parentheses is this guy right here. So now we need to divide by delta x still. So this is going to be x squared plus 2x delta x minus 2x minus 2 delta x minus 3 minus x squared plus 2x plus 3 all over delta x. If I went too fast there, pause it, rewind it, and watch it again. The x squareds cancel out, the 2x's cancel out, and the 3's cancel out. So all we're left with here is 2x delta x minus 2 delta x over delta x. When we divide everything by delta x, we get 2x minus, oops, this guy's got to be, whoops, wait a minute, 2x minus 2. Okay? So what? Well, this right here, okay, this is the slope at x. So whatever you pick, if I pick 2 and I plug 2 in here, I get 4 minus 2, which is 2. So guys, the slope of this blue line is 2. When I plug 2 in, I get 2 times 2 minus 2, which is 2. If I plug in the value 1, if I plug in 1, I get 2 times 1, so this is 1 right here. 2 times 1 is 2, minus 2 is 0. So the slope of this guy, look at that, it's 0. What about negative 1 right here? What's the slope? I'll draw it in green. What is the slope of this line at negative 1? Well, it's 2 times negative 1, because we use the x value that we're looking for here. 2 times negative 1 minus 2 is negative 4. That's it. So what's cool about this function right here, this new function, we'll write it f prime of x is equal to 2x minus 2. What's so neat about this function is it gives us the slope of the tangent line anywhere that we ask, even at pi or at e or whatever number we happen to ask. So anyway, that's the end of the video.